Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to learn an important concept of calculus, that is integration. As I have already talked a little bit about integration and differentiation in my introductory lecture. In differentiation, our goal is to find slope of tangent at a given point, while as in integration, our goal is to find area under a given curve between two given points. Also, in differentiation, we break something into small pieces to find how it changes, while as in integration, we bring small pieces together to find how much is there. Thus, differentiation and integration are reverse of each other. We know that differentiation of x square is 2x. Thus, if we integrate 2x, we must get x square. The integration is categorized as indefinite integration and definite integration. First, we will talk about indefinite integration or anti-differentiation, where we have to find all the antiderivatives of a function. The process of finding all antiderivatives of a function is called anti-differentiation or integration. The symbol elongated s is the symbol used for integration and is called the integral symbol. We write integral small fx dx is equal to capital Fx plus c, where capital Fx plus c represents all possible antiderivatives of small fx. The integral small fx dx is called an indefinite integral. Small fx is called the integrand and c is called the constant of integration. Let me explain it this way. We know that differentiation of x cube is equal to 3x square. Now what we did here, we have subtracted 1 from the exponent, so we get x square, and we have multiplied this with the exponent, that is 3, to get 3x square. Thus on differentiating x cube, we get 3x square. If we integrate this function 3x square, we must get x cube, as differentiation and integration are reverse of each other. Now what should we do for that? We have to do the reverse process. What we have done in differentiation, we have to do the reverse of that in integration. So let us integrate 3x square Now, in differentiation, we have subtracted 1 from the exponent. In integration, we will do the reverse. That is, we will add 1 to the exponent. And here, in differentiation, we have multiplied this with the exponent. So here, we will divide by the exponent, and 3 was already there. Now that is equal to 3x cube divided by 3, and that is equal to x cube. Thus we get integration of 3x square equal to x cube. Now let's take one more example. Now we know that differentiation of x raised to power 4 is equal to 4 times x raised to power 3. Now here we have subtracted 1 from the exponent to get x cube, and we have multiplied this x cube with the exponent 4. Now on differentiating x raised to power 4, we get 4x cube, and if we integrate 4x cube, we must get x raised to power 4. Now for that, we will do reverse of this differentiation. Let's integrate 4x cube, that is equal to 4 is there. Now in differentiation, we have subtracted 1 from the exponent. Now in integration, we will add 1 to the exponent. That is the reverse process. Now again, in differentiation, we have multiplied this x cube with the exponent 4. In integration, we will do the reverse of that. We will divide by the exponent. So we get 4 x raised to power 4 divided by 4, that is equal to x raised to power 4. So in this way, we get integration of 4x cube equal to x raised to power 4.
Now look here, we have functions x square plus 4, x square plus 3, x square minus 6. If we differentiate x square, we get 2x. If we differentiate x square plus 4, we get 2x. If we differentiate x square plus 3, we get 2x. If we differentiate x square minus 6, we get 2x. Thus, if we differentiate any of these functions, we get 2x as their derivative. Since integration and differentiation are reverse of each other, therefore x square plus 4, x square plus 3, x square minus 6 are all antiderivatives or integrals of 2x. Thus, if we integrate 2x, we can get x square. We can also get x square plus 4, or we can get x square plus 3, or x square minus 6, or in general, we get x square plus c. C can be 0, c can be 4, c can be 3, c can be minus 6, or we can say c can be any real number. Now let me explain it this way.
We know that differentiation of x cube is equal to 3x square. Also, differentiation of x cube minus 2 is equal to 3x square, as differentiation of constant is 0. Here, differentiation of x cube plus 5 is again equal to 3x square, as differentiation of 5 is equal to 0. Now, differentiation of x cube is equal to 3x square. That means antiderivative or integration of 3x square is equal to x cube. Here, differentiation of x cube minus 2 is equal to 3x square. That means antiderivative of 3x square is equal to x cube minus 2. Again, differentiation of x cube plus 5 is equal to 3x square. That means antiderivative or integration of 3x square is equal to x cube plus 5. But we have just learned that integration or antiderivative of 3x square is equal to x raised power exponent plus 1 divided by the resulting exponent, that is equal to x cube. But from above we have learned that antiderivative of 3x square can be equal to x cube. It can be x cube minus 2. It can also be x cube plus 5, or in general it can be x cube plus some constant. So to make it more appropriate, we add c to this equation. So we get x cube plus c. This c, it can be 0 like in this case, it can be minus 2 like in this case, it can be 5 like in this case. Now x cube plus c represents every possible antiderivative of 3x square, while c is called integration constant or constant of integration. Now, to generalize this result, we can write antiderivative of x raised power n is equal to x raised power n plus 1 divided by n plus 1 plus constant of integration c. Here n cannot be equal to minus 1, because if n is equal to minus 1, then here in denominator we get minus 1 plus 1, that is equal to 0. So it becomes undefined. Therefore, n can be any number except minus 1. Now, let us take one more result. If we want to integrate some constant k, so we can write it like this: k integral of dx or k integral of x raised power 0 dx, where x is not equal to 0. Now x raised power 0 is equal to 1, so we get k integral of dx. Now using this generalized result, we can write k x raised power 0 plus 1 divided by 0 plus 1 plus integration constant c, that is equal to kx plus c.
Thus, integration of constant k is equal to kx plus c, and integration of x raised power n is equal to x raised power n plus 1 divided by n plus 1, where n is not equal to minus 1. I will continue this topic in my next lecture. Till then, take care of yourself. Thank you.